Okay, so we're going to do 2 examples of each type. And first we're going to do a couple examples of independent samples. So if you are going to have independent samples, you have these 3 conditions that have to hold. You have to have random and independence within each sample. You have to actually have determined that those samples are independent from each other. And you have to have that large sample size. Okay, so the first example we're going to do is a confidence interval. So it says using random independent data, so that's like check for bullet 1, random and independent, about pulse rates was collected from nearly 800 people. Well, right there I can say, well, that's bigger than 25, so check on bullet number 3, to see whether it is plausible that men and women have the same population mean. 384 women were observed, and we found their mean pulse rate and standard deviation. And then 372 men were observed, and they had their own mean and standard deviation. Are the conditions met for using the confidence interval between 2 independent means? Well, I've already checked off, again, 1 and 3. So the only other thing we have to check off are, do we really believe these samples are independent from each other? If it's a random group of men and a random group of women that were studied, these should be independent from each other. They're 2 completely separate groups. It didn't tell us, again, any kind of a relationship between them that would lead me to think paired. So yes, these are independent samples. Okay, so we want to find a 95% confidence interval and explain it in a clear sentence. We're going to let women be sample 1 and men be sample 2. So that was just what was decided. When you're in charge, you can decide what's 1 and 2, and then you just have to make sure you stick with that for the rest of the problem. Okay, so let's see. We need to go to StatCrunch. We're going to go into our T-stats area. This time, notice we're not going to 1 sample. We're instead either choosing 2 sample or paired. So when it's independent, you click 2 sample. We have summary information here. Then I need to record all of this for each one. So sample 1 we had decided was the women. So hopefully you have your sheets out in front of you. I've got one out to the side of me right now. It said that the women's mean pulse rate was 76.3, because this is way too much to remember. The standard deviation for the women was 12.8. And the sample size there were 384 women. And then for the men, there was a mean of 72.1, a standard deviation of 13, and a sample size of 372. We are finding a confidence interval for the difference between those, and we do want the standard 95% confidence interval, so I can leave that alone. Hit compute, record my lower and upper limits on my paper. So that confidence interval is 2.36 to 6.04. And again, we were doing women minus men when we did this. That was the order it was going in. So I could say something like, I am 95% confident that the difference, because everything when you're doing 2 samples, it's all about the difference between them. So that the difference between women and men's pulse rates is between 2.36 beats per minute and 6.04 beats per minute. And furthermore, what I might go on and say is that since all the values in this interval are positive, and I remember the order I was subtracting in, I was doing women minus men, and I got back all positive values. And what that tells me then is that the women's pulse rate is higher. So something like, I am confident that women have a higher mean pulse rate. Does this interval capture 0, and what does that show? So in this case, is 0 inside there? No. 0 is not in that interval. So it is not plausible or possible that the mean pulse rate for men and women is the same. That's what a 0 would mean. If there is a 0 in there, it would mean it's at least possible that their pulse rates are the same. So when 0 is not in there, it means that it's not even possible. Based on this information anyway, it's not even possible that they're the same.